Good morning, good afternoon, good evening, class. I'm here as Ngoga. I'm here for helping you to study the clinical pharmacology, where we are going to start on the first topics, which is called infectious agents. Before presentation of these topics, I'm going to explain the learning outcomes for these topics, where the first learning outcomes is to explain what is meant by selective toxicity and discuss its importance in effective therapies. The second is to differentiate between broad spectrum and narrow spectrum drugs. The third is to define resistance to anti-infectives and discuss the emergence of resistance strain. The fourth is to explain ways to minimize the resistance. Fifth is to describe the three common adverse reactions associated with the use of anti-infective. As introductions, anti-infective agents are drugs designed to target foreign organisms that have invaded and infected the body of human host. That drugs are used for killing or inhibiting the growth of the microorganisms that affect the human host. Also, the use of drugs to treat systematic infections began with the Paul Ehrlich in 19th century in 1920. So, the Ehrlich research to develop the scientific chemical that would be effective only against infection-causing cells, not human cells, lead the way for the scientific investigation of anti-infective agents. This means that these agents are also produced for fighting against that microorganism, not the human cells. So, in the late of 19th century, scientists discovered penicillins in mold sample. In 195, the sulfonamide were introduced also. So, you must put this 1920 in your mind, because in the card, also in the exam, it can be included, where they can ask when the first antibiotics has introduced. So the first discovered is the penicillin, where it's discovered in 1920. So since then, the number of anti-infective available for use has grown tremendously. However, many of the organism-based drugs were designed to treat and rapidly adapting to the repair the effect of anti-infectives. Much work remains to deal with these emergent strains. I'm going to talk on the selective toxicity of anti-infectious agents. Firstly, the selective toxicity drugs. It is the drugs which go and kill or inhibit the infectious cells, not the human host. It affects the microorganism, not the host. So, anti-infective agents target foreign organisms of infecting the body of the human host. Unfortunately, they don't possess selective toxicity, which is the ability to affect certain proteins or enzyme system used only by the infecting organism, but not by the human cell, as I told you, as a selective toxicity. All living cells are somewhat similar. Therefore, no anti-infective drug has yet been developed that does not affect the host. Just now we are going to talk about on the classification of anti-infectious agents. So after we will continue for determining it in details, but the anti-infection agents include antibiotics for bacterial infections, we have antiviral, we have antifungal, we have antiprotozoa for infections caused by the specific protozoa, like malaria, for example. We have also the antiemetics for infection caused by the worm. So the next is therapeutic actions of the anti-infection agents. It also as how those anti-infections act on those microorganisms. So firstly, the infectious agents may act on the cell of invading organism in several different ways. The goal is to interfere with the normal function of the invading organism to prevent it from reproducing and cause cell death without affecting host cell. So some anti-infectives interfere with the biosynthesis of the pathogen cell wall. So Because bacteria cells have slightly different composition than human cells, this is effective way to destroy the bacteria without interfering with the host. Generally, anti-infective can affect cell by disrupting the cell membrane, interfering with the DNA synthesis, altering RNA, or blocking the use of essential nutrients. This means that the mechanism of the anti-infectious. The first is anti-infective can affect the cell by disrupting the cell membranes or interfering with the DNA synthesis, altering RNA, or blocking the use of essential nutrient. That is the mechanism of how those anti-infective act on that microorganism cells. As you see here on this scheme on the graph, we have 4 mechanisms of that anti-infectious agents, where the first mechanism is membrane disruption. It's also that drugs destroy the membranes of that microorganisms. So the second is the RNA alterations, where they inhibit the multiplication of the multiplication of the RNA. The third is the DNA synthesis alteration. It also inhibits the synthesis of the DNA. The fourth is the blocking use of needed nutrient, where they broke the channel where the nutrient pass through and causing the microorganism to die. Yeah, that is the 4 mechanism of that anti-infectious agents. So now we're going to continue on the use of anti-infective agents across the lifespan, where we're going to see the caution, the indications of these anti-infective agents on the lifespan, where we're going to start firstly on the children's. So yearly exposure can lead to yearly sensitivities. This means that if you use that anti-infectious agents to the children yearly, it can cause the sensitivity to those children's. Anti-infective should be used with caution among this category of the people, where they say that medication can be used if it is needed, not used when there is no need for use it. So, as controversy is widespread regarding the use of antibiotics to treat ear infections. So here they say that those many anti-infectious is used, or antibiotics used for treating ear infections. So they are controversial ideas that the habitual use of antibiotics for what might well be viral infection has contributed greatly to the development of resistant strain. This means that there is some nurses or doctors which they use that antibiotics on the disease which is caused by the viral infections, and they use that antibiotics and contribute or develop the resistance in the children. So because the children have or can have increased susceptibility to the gastrointestinal GI and nervous system effect of anti-infections, monitor hydration and nutritional status carefully. So on the adults often demand anti-infective from a quick cure of the various signs and symptoms. The second, drugs, allergy, and the emergence of resistant strain can be a big challenge. Extreme caution is required among the pregnant and nursing women in the use of anti-infective. Also, I know you have run the general pharmacology, where you know the drugs which used on the pregnant woman and the drugs which is not allowed to the pregnant women. Many of them can affect the fetus and also cross into the breast milk, leading to the toxic effect in the neonate, as you know that. On the older adults, older patients often don't present with the same signs and symptoms of the infection that are seen in the younger people. Culture and sensitivity tests are important to determine the types and the extent of the many infections. This is because that in the younger, the signs and symptoms also present quickly. Then also in the older adults, the signs and symptoms are late, so there is need for capturing and making the sensitivity test for seeing the types and the extent of the many infections. This where they use for gathering the information or the infections that attack that older adults. And also the older adults, on the older patient is susceptible to the severe adverse GIT, renal and neurological effect, must be monitored for nutritional status and hydration during anti-infective therapy. Anti-infectives that adversely affect the liver and kidney must be used with the caution in older patients who may have decreased organ function. As you know, when the people are growing, it's also their organ decrease its functions. That's why in that the older adults, we can use that medication which reduce the function of the liver for metabolic that drugs. But if you administer the drugs which have high metabolic rate in the liver, it also inhibit or cause some adverse effect on the liver. That's why we can administer the drugs which have, or the drugs which doesn't cause the adverse effect on the liver, so that they say that we have put in consideration that medication we are going to administer to the older adult. So we are going to see the anti-infective activity or spectrum activities of that anti-infective, where is included in the narrow spectrum and broad spectrum. So the first, the anti-infective agent vary in the spectrum of activity, that is to mean very vary in the effectiveness against invading organisms. So the second, some anti-infective are so selective in their actions that they are effective against only few microorganisms with the very specific metabolic pathway or enzyme. These drugs are said to have a narrow spectrum of activities. This means that the drugs which are narrow, that have narrow spectrum of activity, they act on some microorganisms, but they don't act on all microorganisms, whereby other drugs interfere with biochemical reactions in many different kinds of microorganisms. These anti-infectives are therefore useful in the treatment of the wide variety of the infections, and they are said to have broad spectrum of the activity, where these agent or anti-infections which are broad spectrum of activities, they act on all microorganisms, so that what you call the broad spectrum of activity. So also on the anti-infective activities, we have the bactericidal, we have the bacteriostatic activities. So the first anti-infective that are so active against anti-infective microorganism to actually cause the death of the cell, they affect the cell to be bactericidal. That bactericidal anti-infective activities, it's also those drugs which cause the microorganism to become dead or to become deaf. Also, it means that bactericidal, it kills the microorganism that infect the host. Also, the anti-infectives that are not as aggressive against invading organisms, interfering with the ability of the cells to reproduce or to divide, are said to have bacteriostatic activities. With that bacteriostatic activities, it inhibits the growth or reproduction of that microorganism. That means that if the bacteria doesn't grow or doesn't reproduce, it also invades the host. So several drugs are both bactericidal and bacteriostatic, often depending on the concentration of the drug that is present. Many of the adverse effects noted with the use of anti-infectives are associated with the aggressive properties of the drugs and their effect on the cells of the host, in addition to the those of the pathogen. All medicine, all drugs were administered to the patient or to our client, we must depend on the human immune systems. So we are going to talk on the human immune response. The goal of the anti-infective therapy is to reduction of the population of the invading organism to the point at which the human immune response can take care of the infection. This means that the anti-infection drugs, they affect or they reduce the population of the microorganism, and also the immune system do its work for removing that microorganism in the body. If the drug were aggressive enough to eliminate all traces of an invading pathogen, it also might be toxic to the host. means that if the drug have the capability to remove all microorganism in the body, it also can be toxic to the host. If a person is immunocompromised or have low immunity for any reason, the immune system may be incapable of dealing effectively with the invading organism. It's difficult to treat any infections in such patients because anti-infective drug can't totally eliminate the pathogen without causing severe toxicity in the host. That means that if the person have low immunity and use only that medicine, it can produce the toxicity in the host, where it can produce the adverse effect on the host. Also, this patient don't have the immune response in the place to deal with the even few invading organisms. Now, we are going to talk about on the natural microbial resistance. Resistance can be naturally or acquired. Refers to the ability over time to adapt on the anti-infective drug and produce cells that are no longer affected by the particular drug. Because anti-infectives act on the specific enzyme system or biological processes, as I told you on the mechanism, many microorganisms that don't use that system or process are not affected by particular anti-infective drugs and are said to have natural or intrinsic resistance. So it means that if you use the medications or the drug which hasn't actions or hasn't inhibit the enzyme or biological processes, it also other microorganism doesn't affected on that medicine, that we call the natural microbial resistance. And also we are going to talk about on the acquired resistance. Since the advent of anti-infective drugs, microorganisms that were once very sensitive to the effect of particular drug have begun to develop acquired resistance to the agent. This can result in the serious clinical problem, the emergence of the resistant strain of bacteria and other organisms possess a threat. Anti-infective drug may no longer control potential life-threatening disease and an uncontrollable epidemic may occur. But also, microorganisms develop resistance in the following ways. The first, producing an enzyme that deactivate the antimicrobial drug. For example, some strain of bacteria that were once controlled by the penicillin now produce an enzyme called penicillase, which inactivate penicillin before it can affect the bacteria. Changing a cellular permeability to prevent the drug from entering the cell or altering the transport system to exclude the drug from active transport into the cells, altering binding site on the membrane or ribosomes, which then no longer accept the drug, producing chemical that act as antagonist to the drug. That's how the resistance can be developed between the microorganism and anti-infectious drug. The development of resistance depends on the degree to which the drug acts to eliminate the invading microorganisms that are most sensitive to its effective. The cell that remain may be somewhat resistant to the effect of the drug, and with time, these cells form the majority in the populations. These cells differ from the general population of the species because of slight variation in the biochemical process or biochemicals. So, as continued acquired resistance, the drug doesn't cause mutation of these cells. It simply allows the somewhat different cell to become the majority or dominant group after elimination of the sensitive cells. In another circumstance, some microbes may develop resistance through the actual genetic mutation. A mutant cell survives the effect of the antibiotic and divide, forming a new colony or resistance microbes with the genetic composition that provide resistance to the anti-infective agents. So also, thank you for attending this class. This is the part 1 of the anti-infectious agent. Also the part 2, it will continue on the prevention of the resistance and other details of anti-infectious drugs. Thank you for your attention. You have to subscribe for helping you to get another tutorials or notes. Thank you. God bless you.